Have you ever looked up at the night sky and wondered, if space is full of stars, why is it so dark? It feels like a mystery, right? Stars are shining everywhere, yet space looks like an endless black void. Stick around, because the answer might surprise you. Light is a special kind of energy that travels in waves, and it's what allows us to see the world around us. Imagine light as a fast-moving wave racing through space at an incredible speed. About 300,000 kilometers per second or 186,000 miles per second. When you switch on a light bulb, it sends out these waves in every direction. They travel through the air, and when they reach your eyes, they help you see the light. In space, light travels just as fast but without the air, moving across vast distances from stars to Earth. That's why we can see the stars twinkling in the night sky, even though they're so far away. The universe is expanding like a balloon being blown up. Imagine you have a balloon with dots on it. As you blow air into the balloon, the dots move farther apart from each other. In the same way, as the universe expands, galaxies and stars move farther apart. This happens because space itself is stretching, so the distance between objects grows over time. The universe started expanding from a tiny hot point about 13.8 billion years ago and keeps growing bigger today. The distances between stars and galaxies are incredibly huge. To give you an idea, the closest star to Earth, other than the Sun, is over 4 light-years away. A light-year is the distance light travels in 1 year, which is about 9.5 trillion kilometers, or 5.9 trillion miles. Galaxies, which are collections of billions of stars, are even farther apart. For example, the nearest galaxy to us, called the Andromeda Galaxy, is about 2.5 million light-years away. These vast distances mean that even though there are many stars and galaxies, they are spread out very far from each other. As light travels farther from its source, it spreads out and becomes dimmer. Think of it like a flashlight beam getting weaker as it shines farther away. When light travels long distances, it spreads out over a larger area, so each part of that area gets less light. This is why stars and distant galaxies look faint in the night sky. The farther away something is, the less light reaches us, making it appear dimmer. Cosmic microwave background radiation is a faint glow that fills the entire universe. It's like the leftover heat from the Big Bang, the huge explosion that started the universe about 13.8 billion years ago. Even though we can't see it with our eyes, special instruments can detect this glow. It's spread out evenly across the sky and helps scientists learn about the early universe and how it has changed over time. Cosmic microwave background radiation provides a faint glow that's everywhere in the universe, but it's too weak for our eyes to see. This glow is made up of very low-energy light waves, which are different from the bright light we usually see. Our eyes are not sensitive enough to detect these faint waves, so we need special equipment to measure them. This faint glow helps scientists understand what the universe was like just after the Big Bang, even though we can't see it with our eyes. Interstellar dust and gas are tiny particles scattered throughout space. When light from stars or galaxies travels through space, it can bump into these particles. Some of the light gets absorbed, which means it is taken in by the dust and gas and doesn't reach us. Other light gets scattered, meaning it changes direction and spreads out. Because of this, light from distant stars and galaxies can appear dimmer or even hidden from view. This is why some parts of space look darker or less clear, even though there's light traveling through them. When light from stars passes through space, it can run into dust and gas. This makes the light weaker or changes its direction, kind of like how fog can make it hard to see things clearly on Earth. As a result, stars and galaxies can look dimmer or even disappear from sight. The more dust and gas there is, the harder it is to see what's behind them, which affects how clearly we can view things in space. Our eyes are amazing at sensing light. When light hits our eyes, it's like flipping a switch. We suddenly see the world around us, full of color and life, but in darkness, it's a different feeling. Without enough light, our eyes struggle, and everything becomes shadowy or fades away. In space, it can feel strange because even though stars are out there shining, their light is so far away that our eyes can't catch it. That's why space feels empty and dark, even though it's filled with wonders we just can't see with our eyes alone. Space feels mysterious because, even though it's full of stars shining with light, it still looks dark to us. The stars are so far away that their light gets spread out, becoming too faint for our eyes to catch. It's like being in a huge room with tiny candles far in the distance. No matter how many candles there are, the space between them will still seem dark. Our eyes just aren't strong enough to see all that distant light. So, even though space is filled with glowing stars, it looks like an endless sea of darkness to us. The vast darkness far outweighs the light. While there are billions of stars scattered across the universe, the sheer emptiness of space is overwhelming. This immense void creates the feeling that space is almost completely dark. Imagine being in the middle of a desert at night. Even if you could see a fire burning miles away, the area around you would still be dark because that single source of light isn't enough to brighten the entire desert. The universe works in a similar way. Stars may shine brightly in certain areas, but most of space remains untouched by their light. And the final explanation to this is Olbers' paradox. The Olbers paradox is a puzzle about why the night sky is dark. If the universe is infinite and filled with stars, then no matter where you look, your line of sight should eventually hit a star. That would mean the sky should be bright everywhere, even at night. But obviously, the night sky is mostly dark. The solution to Olbers' paradox lies in the fact that the universe isn't infinite in time. It's expanding, and light from the farthest stars hasn't had enough time to reach us yet. Also, as space expands, light gets stretched and dims, making the distant stars less visible. In short, the night sky is dark because the universe isn't old enough for all the light from all the stars to reach us. If you loved exploring the wonders of space with us, please give this video a like and subscribe to the channel. Every like and share means the world, and it helps us continue this incredible journey together. There's so much more out there waiting to be discovered, and I can't wait to explore it with you.